Okay, hi guys. This is going to be the video to the expressions worksheet I sent out last week. Please pardon if you hear a constant buzzing. It's the construction workers outside my house, and I'm wearing my noise cancellation headphones to film this because they have a mic, but they're not really noise cancellation, I guess, because I can still hear them. But I hope it doesn't go into the video, but we'll see. And if they do, I don't know. It's out of my control. It's not like I have this a chainsaw on my roof. I just want you guys to know whatever they're doing out there. Okay, so let's see. We're going to start with the first question, right? So the first question was asking which of the following is equivalent to 6x squared y plus 6xy squared. All right, so you're saying which of the following is equivalent. You have a few options for your A, B, C, and D. The easiest way, this is almost like a warm-up question, right? They just want you guys to be able to factor out what you can factor out from both terms here. So you have a term here and you have a term here, obviously, right? So obviously you have a 6, right? And as you factor that out, you'll get x squared y plus xy squared. Is there a better blue? Yeah. Okay, so right, so and then what else can we see? Well, from this term, right, we can pull out a x, right? Because there's an x here and an x here. Actually, you can pull out an x and a y. So you can pull out 6xy, right? So if I take xy out from this first term, I'm just going to get an x, right? And the y, there's only one y, so it's left there. Or you can leave times 1 if you want. Plus, well, from this term, there's only one x, so you pull out that x. And then there's two y's because it's y squared, so you have a y left, right? So you're left with 6x times x plus y, right? So this should be answer A. This is answer A. Okay, now let's look at number 2. All right, so number 2 says, if A does not equal 0, then what is 1 over A plus 3 over 4? All right, what is this equal to? Well, the first thing, this is just making sure you guys know how to add fractions, and you're putting in like a number here on the bottom to, I guess, confuse you guys if it's not a number. But you treat it like it's a number, right? Because it tells us A does not equal 0. So the first thing we want to do is get same bases. So to do that, we're going to take a 1 over A, we're going to multiply this by 4 over 4, plus 3 over 4, and then we're going to multiply this by A over A, right? And we can do this because A over A is just 1. Of course, 4 over 4 is just 1, so we're really not changing this expression here in white at all, right? We're not changing the value of it, we're making it friendlier so we can work with it. So now we're just multiply here. 4 times 1 is 4, 4 times A is 4A, because again, to add fractions, you want to get the same base. 3 times A is 3A, 4 times A is 4A, right? So now what you get is, now you have the same base here and here, so you just add these two numbers, and you'll get 4 plus 3A over 4A. And this is equal to A. This is the answer you should have been, was A. Okay, now let's look at another one. Let's see, so number 3 is, which of the following is equal to x squared plus y over y plus, times y plus z, right? So here we're just going to do our distribution. We'll do this for x squared, and then we'll do y here, right? So let's do the white, what I said first. So we do x squared times y is going to be x squared y. X squared times z is plus x squared z, right? Now let's look at the blue. Y times y, of course, is your y squared. Y times z is just plus yz. So this should have been, let's see, this is x squared times z, y squared. So this should have been B, right? This is just probably just checking if you can FOIL out things with different variables. So you have 3 different variables here, x, y, and z. All in all, not too bad, right? So let's see, let's go to number 4. So this is 4 plus 8x over 12x, right? Okay, so the first thing they want us to look like, they want us to simplify. It says x is not equal to 0 because right, and that's good, right? Because if x was 0, then this would be undefined. So here on the top, it looks like I can for sure take a 4 out, right? So this whole thing is going to be equal to 4 times 1 plus 2x, right? And then this on the bottom is going to be 4 times 3x, right? And in case you guys don't see this immediately, just distribute this 4 right here, right? So 4 times 1 would be 4. That's where you get the 4. 4 times 2x is, of course, 8x. That's where you get the 8x. Now here, 4 times 3x is 12x, right? So that's where you get this 12x. So anyway, once we have our 4's here, since this is being multiplied, this is being multiplied, we can cancel that 4 out, and you're just left with 1 plus 2x over 3x. And that, of course, is going to be c. So that's, if you guys got c, you're on the right track. Okay, let's look at number 5. 5 says we have 3x to the 4th minus 3, right? And which of the following are equivalent? Okay, so let's see. So the first thing we want to do when you're given a question like this is simplify it, right? You want to factor things out if you can, make your life easier. So of course we can see we can factor out 3 here, right? Because you have 3 times x to the 4 minus 1, right? Okay, so now what? Well, this looks, basically, we want to see if we can apply any of those formulas we learned from last week, right? Which is you have your a plus b squared, a minus b squared, a squared minus b squared, and see if any one of those look like they fit. Well, we know this, and certainly 1, these are both squares, right? Because I can rewrite this. I'm going to rewrite this whole thing as 3 times x squared to the squared minus 1 squared, right? Now this fits the form if I say, right, let a equal x squared and let b equal 1, right? So knowing this, our substitution here, right, this is going to come down to 3. It's going to be a squared minus b squared, right? And let's just double check, right? Because again, we're saying b equals 1 and a equals x squared. So wherever I see my x squared, like here, I'm just going to put a. And whenever I see my 1 squared, here, I'm just going to put there, right? So now we have this form, right, which is a squared minus b squared. And we know from the video last week, that's one of the 3 formulas we want to commit to memory and just get used to seeing because it comes up a lot. So what you're going to get is 3 times a plus b, a minus b, right? So now what we can want to do is substitute this all back in. So it's going to be 3 times x squared plus 1, x squared minus 1, right? So let's see. So what we have is, and again, of course, right, because all we said is our a is x squared and our b is 1. So that's how we got this here, underline, what I'm underlining here in blue. That's how we got this. So now that we have this, let's see if this is an answer choice. So looking at the answer choices, none of these fit, right? You cannot automatically see A doesn't fit, B doesn't fit, C certainly doesn't fit. So the only one you're really left with is D. But that shouldn't be the best justification. And if you're in a time crunch, of course, since you're not penalized on the SAT for guessing, go ahead and bubble D in. But if you have enough time, we can see this is just going to be the same formula where A is x squared and B is 1, right? So now what you're really going to have is 3 times x squared plus 1 times a squared, sorry, the abx, a squared minus b squared, right? And this is going to be 3 times x squared plus 1. And this now is going to be a plus b, a minus b, where instead of a being x squared, you get x plus 1, x minus 1, right? And of course, now this leads you to d. This is exactly d. Now, we could have done this without recognizing that, breaking this down again. But it's good to see. It's good to see that, knowing these formulas, the a squared minus b squared, the a plus b squared, the a minus b squared, those formulas come in handy, and you can start seeing patterns, and you can do the questions much quicker. Okay, so let's look at number 6. Number 6 is x plus 1 squared plus 2 times x plus 1, y plus 1, plus y plus 1 squared, right? Let's see. So you have something squared here, another thing squared here, and then that same thing being multiplied with the 2 in front. So this, if you see this on the test, this should immediately jump out to you as one of our formulas. And the formula that comes to mind is going to be this, right? Because this is a squared plus 2ab plus b squared, right? Do you see how this follows that formula here? And of course your b, right? So what's our a, right? Think about what could the a be? Well, the a is just going to be x plus 1, and the b is just going to be y plus 1, right? So what's 2ab? Well, that's of course just going to be 2 times x plus 1, y plus 1, right? If we said this is true, then this is true. So that's what we have. That's all what we have here, right? So what does that tell us? That tells us that we can simplify this into a plus b squared. But you got to tell me, what is our a and what is our b? Well, your a is x plus 1, right? So that's going to be plus y plus 1 all squared, right? And again, this is only because a is equal to x plus 1 and b is equal to y plus 1. So I'm just saying, right? Oh, that's not b. Nope, not b. This is b, right? And this is a, right? We're just following this rule here. We're just following this rule. So really what you're saying is, so now let's see, we have our a plus b, so the whole thing squared. Well, we can so simplify this. We can do x plus y plus 1 squared. Of course, that gives you x plus y plus 2 squared, right? And that should be C or B. B, right? So do you see how we took something that we recognized as a pattern, and you guys probably saw like, oh, I know that's stirring up a memory from somewhere, right? And then we used one of the rules we know, right? And the rule was a plus b squared, this whole thing. And we just said, okay, well, I'm going to apply the proper substitution. A is going to be x plus 1, b is going to be y plus 1, 2ab is going to be this. And then we did a rule here, a plus b squared. And when you simplify the addition inside the parentheses, you get an answer that's shown. So that's, again, knowing those formulas will give you quick, easy points on the SAT. Okay, so this one is, I like this one. This one, to me, was probably the trickiest one on the assignment. I want to know if maybe you guys did it differently. But you have xy minus y squared, right? Um, okay, good. So let's see what we have here. Okay, just remembering how I did this exactly, what the easiest way to do this. So let's factor out what we can. So on the top, we can take out an x, so you'll have y minus x. And on the bottom, you can take out a y, so you have y x minus y, right? And if we don't see that immediately, just distribute this x here, this y there, this y there, right? So x times y, of course, is xy. X times x is minus x squared. Y times x is xy. Y times minus y is minus y squared. Okay, so now we have this on top, right? Okay, so this is important. So this is x, y minus x, y times x minus y, right? Okay, so now you want to say, like, I know a lot of people are saying, well, wait, can we just cancel this and this? And the answer is not yet. We want to. That would be really helpful. But we can't do it just yet because it's not the same thing. Um, it's kind of the same thing, but not. So what we need to do is get it so we have the x positive and the y negative, right? Because here the x is positive and there's a negative sign in front of the y. It's minus y. Here is y minus x. So what we need to do is multiply this by -1 like this. The whole thing. The top needs to be multiplied by -1 and the bottom needs to be multiplied by a -1. Otherwise, you're changing the expression. Or you're making the expression not equal, because we will be changing it. We will be changing the way it looks, but you're still keeping it equal. Okay, so let's multiply by -1. Okay, so when we do that, right, so we can multiply -1 in here, so you'll get, we'll leave our x, right, a -1 times this is going to be x minus y, right? Now here on the bottom, I don't really want to multiply the negative. I don't have to multiply with -1 by anything, but I'm going to choose to multiply by the y. And I can do this because this whole thing is being multiplied. I'm going to keep my -y there. I'm going to get my x minus y here, right? Okay, so now we have the same thing on the top and the same thing on the bottom. So those can be canceled. So what you're left with is x over minus y. And that's really just the same thing as the same thing as minus x over y, right? Because you can bring this negative to the top or the bottom. It doesn't really matter. So that's how we simplify it, and your answer should have got D. So maybe there's an easier way. If you guys saw it, this trick comes in handy a lot, especially if you take upper level math courses in college. So like you taking your calculuses or uh, courses like differential equations or linear algebra. This little trick will come in handy a lot. And again, the part we want to realize is we wanted to get this to look like this so we can cancel it here and what I'm doing here in white. And we can do that only if, you do the negative here. So yeah, that's kind of, it was a trickier one. Okay, now let's look at 8, right? So we're saying x is greater than 1. Which of the following is equivalent to x minus 1 over 2 plus x plus 5 over 3, right? Which of the following is equivalent to this? Okay, so again, let's just look at what we have here in green. This is just going to be fractions adding fractions. So let's pretend like we just have that problem. So we're going to multiply this by 2, right? Because we want to get the like bases. So you multiply whatever the other base is by itself or on top. That's the same thing at the bottom. So you'll get 3 times x minus 1 over 6 plus 2 times x plus 5 over 6, right? And now we have the same bases. So we're just going to distribute and add. So this is going to be, right, we'll distribute. So I'll do it over here. This is going to be 3x minus 3 over 6 plus 2x plus 10 over 6, right? So now we can just add this. So this is going to be 5x plus 7 over 6, right? So now we have a whole fraction. So this whole thing in the blue parentheses just ends up being this. It's 5x plus 7 over 6. So I'm going to erase this stuff here. And let's see, what we have is 1 over 5x plus 7 over 6. So we have a fraction over a fraction, which is okay. You have the fraction on the bottom. So really on the top, you can have a fraction too, because 1 is just 1 over 1. So now when you have a fraction over a fraction, right, we keep, change, flip. I think that's how you guys say it. I didn't learn it that way, but I'm trying to keep it consistent. So keep, right, we keep 1 over 1. We change, so we're not dividing, we multiply, and we flip. So it's going to be 6 5x plus 7, right? So now we're multiplying fractions, so you just go across. So it's going to be 6 over 5x plus 7. And that is C. So if you got C, you did it correctly. Okay, so now let's look at 9. 9 is 2 plus 1x over 2 minus 1x. Okay, so now let's look at this. This is going to be roughly the same thing. It looks simpler to me, but let's see. So, of course, they say x is not 0. So let's work on the top first, right? So we're going to have x times 2 times x times really 1 times x, right? Plus 1 times 2, x times 2, right? So this is going to be, 1 second, let me see this really quick. 2, x times 2, is this, what am I doing? Is this right? Let's see. X times 2, yes. Okay, yeah, 2x over x plus 2 over 2x. That doesn't seem right. Let me see this really quick. This is, yes, okay, yeah, we're fine. So now what we need to do, we need to multiply this side here by 2, too, right? So this needs to be 2 times 2, or 2 over 2. So now you can get 4x over 2x plus 2 over 2x, right? Because we want to get, the goal is to get the same thing here on the bottom. Right, let me just make sure I did my math right. Yes. Okay, so waiting for the coffee to kick in. Okay, so now we have the same thing on the bottom. So now what we can do is we can do 4x plus 2 over 2x, right? So that's going to be this guy on top. So I'm going to keep that to the side, and let's do this right here. So it's 2 minus 1x. So here I'm going to do, again, times x, times x. Here I'm going to do times 2, right? So I'll get 2x minus 2. So 2x minus 2 over 2x, right? Over x. So still I need to multiply this by 2, so we get 4x over 2x minus 2 over 2x, right? Now let's simplify this. So we simplify this is going to be 4x minus 2 over 2x, right? Okay, so now this is going to be whatever we see here on the bottom. So we have 4x plus 2 over 2x, and that's going to be here on the top. So I'm going to erase this up here on the side. So again, where I got tripped up is like, whoa, we were multiplying it by the same thing here. The denominators here on the same thing. Why is this not giving me something? And that's crucial. You got to remember, you have to have the same things when you're adding fractions on the bottom. So you may have to multiply by, you may have to multiply by another term, which is okay. Just make sure you have the same things before you add the top or the numerators together. So okay, so on the top we have 4x plus 2 over 2x, and this whole thing is going to be 4x minus 2 over 2x, right? So keep, change, flip. So 4x plus 2 over 2x, keep, change, multiply, times 2x over 4x minus 2, right? So immediately those cancel. So now you have 4x plus 2, 4x minus 2, right? And you're close, right? Well, we can factor something out. We can take a 2 out, so 2 from both the top and the bottom, right? 2x minus 1. Of course, now you can't take anything else out, and also you see the answer. See, this is one of the answers, and you feel good about the math, hopefully, when you're taking a test. So you say, yeah, B is going to be it. And again, the crucial part was just making sure you have the same denominator. So right here, what I did is I did 2 plus 1x, right? I had to multiply not only by an x, not only by a 2, right? Since I had 2x here, I had to multiply by another 2. I actually had to multiply by 2x. So make sure you have the same denominators when you're adding fractions. Okay, let's look at 10. So 10 is the expression 8x squared minus 1/2 y squared can be written in the form of 8 times x minus cy times x plus cy. Okay, so what's the value of c? The c is a positive number, they say. Okay, cool. So let's see. We're given this, and it tells us it can be written in this form, right? So this shouldn't be scary. I mean, we have a c, and we're not used to seeing it as a variable, but that's okay because this looks really familiar to one of our questions, or to one of our formulas that we memorized last week, which is this over here looks close to a squared minus b squared, right? Because then that gives us the a minus b, a plus b, right? So in this case, a would be x and b would be cy, right? So instead of just y, it's cy, right? So you can almost think of it, when you multiply the y by c, you're getting some new variable. But anyway, so let's keep this in mind while we're working on through this problem. So we have our 8x minus 1/2 y squared. So I'm going to pull out the 8. I'm going to get x squared minus, now you're going to say, okay, well, you can't pull out an 8 here. That's not an 8. And actually, you can, right? So you can pull out the 8 and you'll get 1 over 16. And I'll show you how that works. It's not hard to see. I think if you guys aren't really used to pulling it out like that, it's a little weird. Like, how can you do that? But I'll show you. So we'll pull out the 8. Of course, this is easy, right? 8 times 8x squared is just, or sorry, 8 times x squared is just 8x squared. What about this? What's 8 times 1 over 16? Right? So 8 times 1 over 16, well, that's just 8 over 16. But what's that? That's 1/2. Right? So when I do 8 times 1 over 16, I get the 1/2 back. So I can really pull an 8 out. And the reason that works is what's happening when you're pulling that 8 out is you're actually dividing by the 8. You're actually, when teachers say pull or factor an 8 out, you're actually dividing by an 8 by this, and you can divide an 8 by this too. So as long as 8 can be divided by the 1/2, you can pull it out. I can do more examples of that, but we kind of showed that if you can distribute it back and get what you originally started with, which is that 1/2, you can pull it out. So just remember that. It may come in handy. Anyway, so let's proceed, right? So now we're close to this form over here, what we want to get. And we're close to we're basically at this point here where we can use this formula, right? So what's our A going to be? Our A is going to be x. What's our b? Our b is going to be, well, this one's a little bit trickier, right? I got to pull out the 2 from here, so 1 over 4 times y, this whole thing squared, right? What does this become? Well, this is y over 4 squared, or y squared over 16, right? So if I pull out the 2, I end up getting that. So that means that then b must be 1 over, or b must be y over 4, right? So b is y over 4. Then we can just apply this formula, right? You can have your a squared minus b squared. So what is this going to be? It's going to be a plus b times a minus b times 8, right? Where a is x plus y over 4 times x minus y over 4, right? And what's the constant? Well, the constant is 1/4, right? What's the number in front of y? Well, it's just going to be 1/4. So it should have been C. Yeah, C. Good for you. Okay. Fortunately, the rest are pretty much straightforward from here. That was much more thorough than uh, most of the other problems. So this one is asking us, we have uh, x squared, x plus 2, x minus 2, plus 4, right? What is this equivalent to? Well, this is giving us the same, that same thing that we saw earlier, right? So it's the a squared minus b squared formula showing up again. In this case, our a is going to be x, and our b is going to be 2, right? So you really get x squared times x squared plus, or sorry, x squared minus 2 squared, right, plus 4. And so now we could just multiply out here. This is going to be x to the 4 minus 2 times 2 is 4 minus 4x squared plus 4, right? So you're close. We're very close to being done, but so this doesn't show up in one of the answers yet, right? So we're going to have to apply one of those formulas again. So what you need to notice is that you have the 4 here, right? And you have your 4x here, but this is really 2 times 2x squared plus 4, right? And this looks like a formula we've seen many times, right? And this is going to be the a minus b squared formula, right? Which is a squared minus 2ab plus b squared, right? So you have your, this is your a, this is your b, this is your a squared, this is your b squared, right? Do we see how we're just using this formula here on the right? So now what we need to do is just say, okay, well, I got it. What's my a? My a is going to be x squared, and my b is going to be 2. So really, it's going to be x squared minus 2 squared, and that is x squared minus 2 squared, a. So it's just applying those formulas. This way, you really want to know them by like the back of your hand. Okay, so 12 through 15 says a calculator is allowed, but we don't need a calculator for these, so we're not going to use one. I don't, because sometimes, I think you can get bogged down with the calculator. So 12 says you have these two polynomials, 3x squared plus 8x squared minus 4x, and then you have 7x squared minus 11x minus 7. Right? What's the summation of these? Well, if you guys remember, it's just you're going to be adding like terms, right? So there's no 3x cubed, so you just bring it here, cancel. There's your two x squared terms, so you have your 15x squared, so those are canceled. You have your minus 11x minus 4x, it's minus 15x, and then of course your constant minus 7. So it's as simple as just adding like terms. Maybe to try to throw you off by putting a x cubed term, but it's just like, you guys should know, right? We have 5x plus 6x squared. That doesn't equal 11x cubed or something, right? It's just adding like terms. So don't get confused if you see something that you're not used to. Stick to the basics, what you know, and math will work out. So now let's look at 13. 13 is 5a plus 3 times square root of a minus 2a plus 5 times square root of a, right? So now you have 5a plus 3 times the square root of a minus 2a minus square root of 5a, right? I just distribute that negative, right? So now these cancel out, I get my 3a. This we're just adding, we're just treating if square root of a were x, right? How would you treat 3x minus 5x? Well, you would just add the constants together. So you have a positive 3 minus 3, and have a minus 2 square root of a. So that is going to be c, right? Now this is probably tricky. You guys haven't done radicals in a while, but again, if you just see something that's being multiplied like this, just treat it like it's a variable. You know, virtually every time actually you'll be fine. That I can think of off the top of my head. Okay, so now we're saying if y does not equal 0, what is the value? I don't want to do the matrix green anymore. Let's do chalkboard. Or no, let's do blue. You know what? Let's change it up. Let's. These last two problems deserve better colors. Okay, 9. Nope, that is not one of them. Yes, 9 times 2y squared plus 2 times 6y squared all over 8 times 3y squared. Right? What does this equal? Well, this question you want to see questions like this, right? If you're solid on the exponent rules, this is an easy question. So you have 9, you have this to your exponent, so this is going to be times 4y squared plus 2 times, of course, that 2 distributes, so you have 6, or I was going to say 6 squared, that doesn't really help us, 36 times y squared, and then times 8 times 3 squared, right? Because that 2 distributes, so 9 times y squared, right? So now we're almost done. So we're gonna pull out a y squared, y squared, y squared, right? You can all pull that out. So that ends up being, right, if I pull it out here, y squared, right, then I could just basically erase that y because we're just saying we pulled it out, right? Same thing here, just pull it out, right? We just pull out that y squared. So then these y squares cancel out. So now on top you have 9 times 4 is 36, plus 2 times 36 is 72. 8 times 9 is 72. So your value should be, I think this is what, 108 over 72? Is that right? 108, 72, yes, 108 over 72. So you can simplify it if you want. I don't, off the top of my head, that looks like 36 over 54, and then I think you can do it by 2 again, 27 over 18. Oh yeah, you can, okay. So then by 3, this is 9, 6, and I think this would be 3 over 2. So your answer should be 3 over 2.